All right, welcome back to Project Syncro, guys. Today we're going to go through a nice new crummy Chinese acquisition I got off of eBay about a month ago. This is my 40-watt CO2 laser cutter engraver. It's a giant piece of junk. Cost me about 350 bucks on eBay, shipped. Came out of some warehouse in California. Got here in about a week, and it's pretty much been a nightmare. So we're gonna go through it today, and I'll show you the reasons why everybody hates it, reasons why everybody loves it, well, what I plan on doing with it, why I like it, things I plan on upgrading, things I don't care about, just a whole menagerie of different reasons why I'm sort of enjoying having this laser cutter. So stay tuned for more. So the basic idea behind the laser cutter is that you've got this giant 40-watt laser tube in the back here. It's water cooled. There's a little water pump in a 5-gallon bucket I've got down below, and you actually pass water over the laser element itself. You'll notice the laser doesn't move. That was kind of what I was wondering logistically, how is this thing going to work? So there's a giant laser tube in the back. The power supply and whatnot is up front, but once you get a laser beam running, if you follow me down this way, we've got a mirror, and that mirror reflects light into this front area where you have a standard XY looking platter head. So the mirror shoots the laser beam to this mirror, which reflects it into a third mirror, sends it down through a little lens element, which focuses it into a very fine beam on this super crappy looking cutting platform I have right now. So you've got two stepper motors, your X and your Y axis, and it works just the same as any other XY plasma table or a basic CNC router or anything would work. Just instead of using a drill or something or a motor, you're using a laser. So a lot of questions I get is, can it cut metal? No, I can't cut metal with this. At least I know I can etch metal. But if I'm going to etch metal, it's got to be coated in some special way. To be honest with you, I have not even touched metal yet. I'm just kind of cutting my teeth on wood and really just cardboard right now. The plan is to design up my electrical panel for the car and hopefully a lot of other kind of control panels and signage in the car, and cut them all out and use them as backlit switch panels. So that's really just all going to be acrylic stuff. I don't know of any situation where I'm going to use anything other than acrylic. I might try and do some etching on some brass, or maybe even do a weird coating on some stainless, but I think that's going to be kind of pushing it for this eBay special. If we move over to the other side of the cutter, you see that we have some little cheesy control panel that's got some Chinglish on it that tells you what to do and what not to do. We've got a little gauge that tells you how much power you're running through the laser itself. You kind of roughly dial it in with a knob, and you can actually set percentage cut power and percentage engrave power within the rudimentary software that they give you. If we look under the panel, you can see that you have a simple power supply to power the laser with an output, or power out and signal from the controller board that's mounted on the front. This control board, again, is pretty proprietary, and I don't know, it's very close to what you would have like an eBay special Mach 3 CNC board, but it's made more specifically for laser engraving. There are a lot of people that say, you know, run this board for as long as you can get away with it. If the board ever fails, again, just jump on eBay or find somebody who has a really nice open source Mach 3 CNC board, and it's just as easy to wire this thing up like a router or a 2-axis CNC machine and just run it like that. So that's pretty much all there is to it. There are a lot of little nuances that are really stupid. There's a lot you have to do to get this machine set up and cutting. Pretty much all the reviews are bad, and you might think, why would somebody as fastidious as me go run out and buy some eBay special hunk of junk. It's mostly to prove that something like this can work if you put a lot of effort into it. Just as everything else I've done, all this stuff can work, but it's not just going to work out of the box. You've got to do a lot of work. Pretty much what I did as soon as I got it, I realized that the fit and finish was not as desired. If you kind of look at the side of the machine here, or you look at the plexiglass, you know, it looks a little scratched. You think, wow, I really banged it around. No, it came like that. It was just pretty much ruined when I got it. Wiring was loose. There was just dirt. It was just full of dirt. I don't know why. It was stored outside of a box or something before it was put together. So the first thing I did when I got it is I completely disassembled it. I unplugged every connector, and I almost didn't do that. I kind of just fired it up to make sure, yes, okay, the laser will actually, you know, project a beam, and okay, good. I don't have to return it or anything. And I noticed there was actually some arcing of current on the meter, on the back of the meter. So I freaked out and said, okay, I've got to take this thing apart even more than I originally thought. So break it down, see what you've got, make sure nothing's ruined to start with, take every single mirror out, clean the mirrors, wash them. Mine had mold on them. Put the mirrors back in, and I won't take you through the mirror alignment process. There are probably 50 videos on YouTube on how to align mirrors on a laser cutter. It just involves putting sticky notes progressively in front of each mirror. You know, you line the back mirror up. Once you know that the back mirror is shining into the platform and it's running nice and parallel, then you run the y-axis mirror. You know, you align it. Then you align the x-axis mirror. And then you pretty much just verify that you get a laser point cutting at all four corners. So long story short, that's what I did. I eventually got everything clean and dialed in and got it cutting. The other little accessories that leave a lot to be desired, this fan right here. If you take a look at this fan, it's pretty much just crappy ABS plastic with a super scary AC motor and very little safety going on. No ground, no nothing like that. It's just a little squirrel cage fan. I haven't had a chance to get a new one yet. This one works for now. Again, like I said, I just want to get this thing running and make sure everything works before I start dumping a ton of money into it. I know it was really cheap, but you know, you'd like to verify that something works. So it comes with this crummy hose. Most of what people do is they take this hose and they throw it directly in the garbage. I've not done that yet because it's not too bad. You know, you'd get like a standard dryer hose or vent or something and run this out a window. That is not optional. I thought, it might not be too bad. I'm going to be in my garage. Maybe I'll just run this for a few minutes and see, you know, maybe it's just going to smell kind of bad. No, the laser is burning whatever it's touching. It's generating smoke all the time, and I pretty much immediately filled the garage up full of smoke. So we'll actually get this thing hooked up so I can push this table back. If you also look at this right here, it doesn't really hook up that well. It's just pretty loose. So the other nice feature I have here is I just push it back up against the wall. So a lot of really sketchy things going on. So I've also got the hoses, as I mentioned, plumbed up in this 5-gallon bucket of water that I just threw a little bit of bleach in and some water in there, and I'm not really worried about putting coolant because who even knows what's going to happen if that glass element breaks. I will say the pump is super scary, and I always, you know, something just doesn't feel right when you take some sketchy Chinese pump and you throw it in some water and then you plug it into the wall. And I kind of got over that fear and did it, and everything was fine. I didn't pop any breakers or anything like that. But a couple days ago, I was making some plaques, and I thought, I'll reach in here and see how cool the water is, make sure my water's not getting too hot and I'm not going to overheat the laser tube, and immediately shocked myself. I don't know, it only seemed to correlate to when the laser was on, but there's some kind of grounding issue somewhere, probably because none of this stuff is grounded. So I'll just say that right now. This is a whole level of sketchiness that you just have to accept and just move forward from. So there are a lot of things you will discover as you take it apart and put it back together that will immediately make it perform better than it did before. So once we've got it set up now, we got the laser line and whatnot, we're actually going to jump over to the computer, throw a little design together, and we'll etch something for you guys. I'll take you through the process of etching. Okay, so I threw a quick design together on the laptop here. My plan is just for right now to just engrave this. We're not going to do any cutting of any shapes or anything. We're just going to take a simple bitmap that I threw together in CorelDRAW, which is the included program. You can use any program, obviously, but I threw that together. It does come with a plug-in to sort of wire the laser cutting portion up to CorelDRAW, and they call it Corel Laser, but that's kind of a load of crap because the first thing I did was jump in there, throw something together in Helvetica, and try to export that and cut it using the plugin, and it immediately failed because it couldn't just export that to some vectorized file or a PLT or SVG or whatever and run it through the cutter. It could only just do that with etching. So pretty lacking on the plugin. I haven't figured out what it can do, what it can't do. So the good news is it includes a second program called Moshi Laser, which is a huge piece of junk. A lot of the stuff is in Chinese. The program crashes a lot, but it does work if you know just how to massage things properly. So actually what I did is I got things set up properly. I expanded all the settings, and I'll actually do this here if it will let me, is pull up the output menu and set everything up how it needed to be to work, because it only works in one fashion, where you have to force it to 0 at the top left corner, which sounds pretty obvious, and you need to set it to engrave from top down. It defaults to like top over to the right or something, and that forces it to like invert axes and gets things confused and just crashes the head immediately. So there's one set of settings that works with your cutter. You need to get it dialed in. It's going to take a while. Cut a bunch of pieces of cardboard, and like I've done, I have a whole stack of cardboard. I cut the box that it came in into nice 9 by 12 inch pieces, which is just what fits in here and what you can cut. So whenever I want to test something, I just throw one of those pieces of cardboard in and test away on it. So once I got that dialed in, I was more comfortable with etching things like wood or cutting some other stuff. But so that's what we're going to do now. We'll do it first on cardboard, and then we'll crank up the power and we'll etch some wood. So what you have to do first, it comes with this little USB license key thing, which there's legitimately something on here. I can't actually browse the file to see what's on here, but Windows did ask me if I wanted to back up the certificate on here, and I actually backed it up to, I can't remember the file extension, but it was the file you would use for like an SSL certificate for a website, which I thought was kind of cute. So don't lose this. If you do, well, when you get it, make sure you can back it up, and but still don't lose it, because I haven't tried to replicate one yet. Again, I've had this for a short period of time. So throw this thing in or it won't engrave. It comes with if you're familiar with USB, the standard USB plug is USB-A. It came with a USB-A, or USB-A is the wide one, right?
I think so.
Yeah, it comes with the standard USB plug, but if you look at the other cable, it's 2 standard USB plugs. So you have to use a special stupid cable. It makes no sense. The other thing I've considered doing is actually building a USB hub into this and leaving a little dongle in there and plug the license key in there. So it's just all in the machine, and you don't have to worry about remembering this stupid little license key. So we'll go ahead and plug the machine in, and I'll turn it on. It gets quite loud, and we'll start engraving some stuff. All right, so we've actually got the laptop hooked up, ready to engrave, and I'm going to throw some material in here, but before I do, I want to show you how I got everything lined up. You'll notice this print bed is just a chaotic aluminum piece of junk with a hole in it. That is because it came with this little spring-loaded clamp, which is just a piece of junk and really scary. So I pulled it out. The print bed wasn't leveled. I had to level it. I'm still going to get either that honeycomb piece of laser cutter base stuff or just cut out a big sheet of stainless and throw it in, because it doesn't matter. It's not that high powered. So what I did once I got this bed laid in here is I put down regular painter's tape, and you can switch the laptop into free motor mode where it unlocks or powers down the stepper motors so they don't lock in place, and just move it around. So I enabled the laser, and I won't do it here, but I enabled the laser, hit the test button to actually power the laser up, and ran a line down the painter's tape. So I got a good, nice, true angle one way, and then really carefully, because if you put your hand in between here, obviously, as I found out, you will burn yourself. And I moved the head over this way without moving the y-axis up and down. So I got a nice square mark where 0, 0 is, where they intersect, and then I can actually use that to determine where to place my objects. So once I cut one thing, if you're cutting multiple things, the little trick that I did, if you see this orange paint in here, is I got something cut and I got it just dialed in how I wanted it, and then I sprayed a little spritz of orange paint on either side as a witness mark, so I knew exactly where to lay my piece the next time. So that worked out pretty well. So I'm going to use the same size pieces I did. I'm just cheating so that this hopefully goes well. And we're going to dial the power back, and we're going to engrave this piece of cardboard with my little file here. So hopefully this will work. The fan actually still does a pretty good job of pulling all the smoke out the back. It definitely could use to be more powerful. I'd venture a guess that one standard PC fan, like a server grade nice fan, would actually pull enough air through to, you know, if you put some vents in the front, have the fan pulling out the back, that would be way more than enough to clear all the smoke out. As you guys know, a bitmap is truly just a map of all of the bits or all the pixels in an image. So it's not truly as crisp as a vector based file that's actually a collection of lines and directions and what have you, but it's still super fine. It's supposed to cut at or engrave at 300 DPI, which is like a standard old black and white laser printer. So it's pretty crisp. It's not bad. I was a little bit worried that it was going to be not as great as I had expected. You know, maybe I'd have some imperfections out of something that wasn't up to snuff, like a Glowforge or a better printer at a higher cost. But I don't think there's going to be any problem cutting the 0.3 inch high text that is common on switch panels. So I was excited once I tested this out to see how fine a resolution it could really cut or engrave even in a bitmap mode. All right, pretty smelly in here, a little bit smoky, but not too bad. I think we just had the thing open, obviously, so we're gonna get a lot of smoke all over the place. Don't don't stare directly into the laser. I think that's a pretty obvious one, although it doesn't really matter. And we have a pretty nice finished product. I mean, even though this is just cardboard, as Kyle and I were saying while this was engraving, it's super accurate for even a bitmap. You can just kind of see some little bit of phasing on the edges and the corners and whatnot, where you see stacks of pixels rather than a really nice curve. But I think it's also because it's on cardboard, some of that stuff is kind of blended. But again, better than expected for what you're paying for here. So we're going to switch gears a little and actually switch this over to a vector-based file. I'm probably just going to drop, well, we'll see. Maybe I'll drop one of these out. We'll increase the size and fatten this up, and just so you can see how this will actually trace the letters when we do a vector cut. I'm not sure if we're going to turn the power up enough to cut the letters out, because I haven't done a whole lot of that, and I kind of don't know that I have the speed correct enough not to just set the cardboard on fire. But we'd at least like to run through it just so you can see what's going on. So a standard workflow on something like this would be like you would engrave something, and then when you're done engraving it, you want to switch gears, crank the power up, and then cut that object out, cut around it. So a lot of really fancy laser engravers or embedded pieces of software will do that all in one. This software, again, it's kind of hokey. It claims it will do it. I think it does it based on, believe it or not, the color of the line. So if you, some people said if you have a red line on something, it knows to just cut that instead of engrave it. Again, I haven't done a whole lot of testing with that. Right now what I'm doing is I'm actually just leaving the piece of work in there without touching anything. And I have layers in my file. So I'll export a file with one layer that's my cut layer. You know, I'll build it all together, and one layer will be my cut layer, and the other layer will be my engrave layer. And I just load the two files separately, back to back. You know, engrave first, close the engrave file, open up the cut file, set it to the cut setting, the cut power, and then cut around it without moving it. A little bit more tedious, but hey, I'm only paying $350 for this thing instead of $1,800 or God knows how much for a top-of-the-line machine. A little bit more work involved, but I'm willing to put in the effort to save a little bit of money initially. So let's switch over to vector and see how well that does. Okay, so we turn this around and jump back into an editor program and just simplified the thing into a vector file. So what I ended up having to save it as a DWG, which is an AutoCAD drawing file. This cutting software, the proprietary MoshiDraw software, gives you like multiple options for what kind of files to import. It'll actually let you design stuff in there too for really simple stuff, but I'm gonna have to prove a point, which is you can grab any file and throw it in and cut it. I started out as an SVG, scalable vector graphic. I think that's what that stands for. An SVG file. It came in upside down and backwards. Didn't know what was going on there. Switched over to an Adobe Illustrator file, an AI file, and it imported that as a vector. But let me see where this is. It actually cut little sections out and sectioned the letters up. So I have a feeling that's a issue with how this was exported, but can't really prove that yet. So we just said, well, we'll just go through these and find a file type that's going to work properly. So a DWG file works, and when I imported it, it came in upside down and backwards, but I noticed there was a little checkbox thing for some reason that said mirror, and you mirror question mark, and hit that, and it flips it to be correctly oriented. So now we have this nice little outlined piece. I made sure to export the text as curves rather than as text, because this file doesn't know how, or this program doesn't know how to interpret TrueType fonts and all that stuff. So just bring it in as curves, and things will work out a little bit better. You can actually see all the different pieces over here. So fingers crossed here. This should actually cut properly, and hopefully I don't have to eat my words here. Okay, so check that out. It actually did work properly. Got a little smoke rolling off of it. But yeah, some of the vectors, I guess, I don't know if it was a vector conversion or just because this cardboard's not super flat, but you can see where some of them start and end, which kind of concerns me a little because I think the engrave setting was a little bit more accurate with a less accurate file. So I don't really know why that's going on. We'll fool around with that a little bit more at a later date whenever we go to actually cut out panels. But I'm excited to see what this thing can actually do now that I've got it set up and it's kind of halfway working. I'm going to make some changes, going to do some upgrades here and there. But you can see for way less than any kind of crazy industrial machine would cost. And when you look at the the volume, if you're going to be making a lot of stuff or doing a lot of trial and error, $350 really isn't that much to spend, considering how much you can kind of fiddle around. What I had originally planned on doing was just doing printouts, and I was going to have a friend laser cut this and just get one panel from him and slap it in. I know now that that probably would not have worked, knowing at how fastidious I am. I know I use that word a lot, but how detail-oriented I am with a lot of stuff. I know I'm going to want to change things, and just being able to walk out here and cut out a new piece and throw it in is going to be super handy. Now, this isn't just going to be for panels. Obviously, that's mainly what I got it for, but I can also do other cool things like if you look at this throttle body, I don't feel like buying gaskets, so why not buy some gasket material, trace this gasket, actually get a nice drawing of what's going on, and then I can cut out my gaskets. So think about how handy that would be rather than going out and buying gaskets if you can just cut out your own gaskets out of a sheet of gasket material and just be ready to go on that. Something else, if you need a really fine angle, I thought of a lot of times on the cage where I needed a little pattern for my foot plate and I wanted to make sure the left matched the right and it needed to be mirrored and stuff like that. It would totally make sense to go into AutoCAD and lay out exactly what I wanted and then laser cut it and then be able to lay it in the car. And you know it's perfect and you know it's repeatable, and I know I'm not sending it to a plasma cutter and cutting out the metal, but this is one step further to being super accurate and repeatable, which is really, really what I want. So I wouldn't say there are 1,000,001 uses. I know a lot of guys are going to say, oh, you can use a 3D printer to do everything. I don't see a lot of 3D printed parts on rally cars. I see them helping stuff on rally cars, just the same as this laser cutter is really going to help me put a lot of stuff together on my rally car. So I'm sure we'll find more uses. If you guys think of stuff that I didn't think of that I could possibly use this for, or you have anything you want me to try and come back and tell you, hey, this machine's going to work for this or it's not, before you go throw a couple $100 into a big blue Chinese piece of junk you have to rebuild, go ahead and comment on the video, send us a message, let us know what you want to see. And as always, thanks for watching. Be sure to like, share, and subscribe all of our videos. I know we've got quite a collection of stuff out there now, and I'm looking forward to actually putting this thing to use and putting some of this stuff in the car in the future. So thanks again for watching, and see you guys next time. Piece of shit.